Hi everyone and welcome. Today we're going to be talking about finding the volume of three-dimensional figures. So your goal after watching this video will be able to understand and calculate the volume of multiple three-dimensional shapes. So to start off, in an applied application to one of the labs here, if we're thinking about an engine and the internals of that engine, if you've ever wondered the cubic centimeters or the cc of an engine, how that's calculated, we can actually take a look, and it's going to be basically using the area of a piston and then how far up and down it goes. So actually that's a different way to say volume. So that's a three-dimensional space inside of an engine cylinder, and as you can guess, cylinder is a three-dimensional shape, and that's how they calculate it. So for an 8-cylinder engine, like a 350 small block for a Chevy, for example, you would take the size of the cylinder, how far the piston goes up and down inside of that cylinder, or the stroke, and you would multiply that by the volume of all 8 of those cylinders. So basically you're finding the volume of 8 of those cylinders and the amount of more or less air and fuel that the cylinders push up and down. So a 350 Chevy, the 350 in that case would mean 350 cubic centimeters of air and fuel volume within the engine. So a bit of a cool application. I always think that this is interesting to think about and to see, and you'll notice that with a lot of different engine sizes, and if you ever were wondering about the liters of an engine or the cc of an engine, this is actually the calculation. It's the volume of air and fuel that flows through that engine. So that being said, we are going to transition to a couple of formulas that we're going to need here. So we're actually going to start off with prisms. And we define the volume of a prism, and this is any prism, rectangular, triangular, any of the above, as the area of the base times the height. So it's base times height, where B equals the area of the base. So for a prism specifically, the base isn't necessarily what's on the bottom. It's the shape that you can trace evenly up and down. So here we have a triangle. We can trace that triangle up and down, straight up and straight down. And because of that, that is the base. The height of that triangle, we're going to see, is how far that triangle goes up and down. So our height is 4. So I'm going to label that. And our base, we're going to have to calculate that. So we're going to need the area of a triangle. So that's going to be 1/2 of the base times the height. And here our lowercase b for base is going to equal actually 5, because that's the distance along the bottom. And the lowercase h here for our height, I'll do this in a different color, is going to be the 1.5 yards. So our base is here of 5, and our height is 1.5. So we're going to multiply these things together to get the area of that base, so our uppercase B. So we'll get 1/2 times 5 times 1.5, and that'll give us an area of 3.75. So the area that's shaded in blue, the shape that we're basically pushing up and down to make our 3D prism here, is 3.75. Our height is 4, so the volume of this shape is going to be 4 times 3.75 for a total of 15. And again, think of prisms as it's almost like you're starting off with a flat shape, and then you expand it out of the paper. And whatever flat shape is being expanded is the base. So here, that's a triangular prism because we're making basically a 3D triangle, or a triangular prism there. If it was a rectangular prism with a rectangle on the bottom that we're expanding, we would take the area of the rectangle on the bottom and multiply that by the height. All right, next, volume of a pyramid is quite similar. Our formula for this is almost going to be the same. It's going to be the area of the base times the height again, except this time we're going to divide all of that by 3. It's actually a pretty cool experiment if you ever have the chance to get your hands on 3 pyramids that are exactly the same, because if you put them together, they make a cube. So pretty cool geometry, and I actually did that with, and we might have time to, I don't know if we will in class because of COVID, but you can do some origami, make yourself 3 pyramids and then if you put them together, they'll actually make a prism, or the cube of the shape that you're making. So that's why we divided by 3, is because 3 shapes actually fit directly into that pyramid like that. So that being said, though, we have to find the area of our base, which is our shape for our pyramid that goes on the bottom here. And then the height goes up to the tallest point here. So first, area of that base. We have a 3, 4, 5 triangle on the bottom. Remember, it's our area is 1/2 base times height. Our base here is 3, and our height is 4. So we're going to have an answer for our capital B that's going to be basically 12 divided by 2, or 6. Our height they give to us as 5, so we can take that as our H term. So we have capital B equals 6, multiply that by our height of 5, divide all of that by 3. So we'll get a final answer for this one of 10. All right. And again, that should be miles cubed, because we're in cubic units here, 3D. And our top one should be yards cubed for our final answer there as well. So a prism and a pyramid, pretty similar formulas, except the difference is the pyramid. We're going to divide that final answer by 3. Let's go on to 2 other examples of things that we're going to see. Next, we'll go to a cylinder. I always liked cylinders. I thought these made the most sense to me, because you basically find your area, and then it just expands it out like that. So you find the area of the base of that cylinder, and then you multiply that again by the height. So if we're looking at this here, what we're going to see is our base, in our formula, sorry, I should say that first. Formula of a cylinder is the area of the base times the height. Our base here is a circle with a diameter of 4, and the area of the circle, a little bit of review if we need it, is pi r squared. Well, we have our diameter equals 4, and our radius is half the diameter, so radius is 2. So area equals pi times 2 squared, or the area of that base is going to be 4 times pi. And we can leave it like that. We don't need to go to the decimal of pi. And then we can take that and we can multiply it by the height. Well, the height is going to be 3. So plugging that back into our volume formula over here, we have 4 pi times our height of 3, getting us a total volume of 12 pi inches to the 3rd power, because again, it's cubic units. All right, our last one is a cone. The volume of a cone, again, similar to that pyramid actually, is it's going to be 1/3 area of the base times the height. So our base this time is going to be a circle with a diameter of 2 kilometers. So our radius is half of that, or 1. So our area of this is pi times 1 squared, or our area is actually just pi. And then we have our height here. How deep this cone is 3 kilometers. So if we plug that into our formula, we have 1/3. Our base area is just pi. Our height, in this case, is 3. And we're going to have volume equals 1/3 times pi times 3. If we punch that into the calculator, it's actually just going to give us an answer of pi. And again, units to the 3rd power, because it's cubic. And that's our final answer. So what I would say is these are 4 formulas that we're going to need. Have these formulas in your notes, maybe with an accompanying example. That way when we get to an assessment, we have them ready to go. We will have some time to practice these in class to get comfortable using them. But again, these are the 4 major formulas. And you can see they're reasonably similar that we're going to be using pretty consistently. So take them, apply them to the remaining questions in the notes. Take a little bit of practice time with those. If you have any questions, as always, feel free to reach out, email any of those things, and we'll get back to you shortly. But hopefully this is a little bit of a review, but I know it's probably been a while since